All right. Yes, I'll discuss the quizzes if you've taken it. So no. So because now you've taken enough stuff that I can kind of talk about the grading process for Runestone. Okay. Which suffice to say, don't panic. Okay, that is the too long didn't listen summary of everything when it comes down to the quizzes and other things. Can everybody hear me over there, by the way? So you're saying I need to talk into this. Okay, great. All right. Let me move over so that this is inconveniently placed because I've got this like drawer right in between here. So it's annoying. Oh, actually, wait. I'll just move here. Now you can see my face if you're over there. That's right. All right. So again, if you're not feeling well or the like, just don't come to class, instead attend the Zoom session. And again, this is a flipped classroom, meaning that we are going to do a lot of work in class as opposed to out of class. If you feel like I'm giving you guys too much work, please let me know so that I can adjust accordingly, because I really don't know unless if I'm giving too much unless people say, wait a second, that's too much. So, but I try not to overwhelm you. Again, this is a freshman level class, so there's a lot of foundational material, which I think is extremely beneficial when you practice on it, when you have a lot of extra small exercises, but I don't want those small exercises to be a bunch of large exercises. Okay, that's why I mentioned that. Now, as far as grading for the Runestone goes, typically the way it works is that if we go to our assignments and go to your readings or something of the like, let's see, you'll hit score me or the like. And what's going to happen is over time is that I just ran what's called the grader on the chapter 1 exercises. So if you go back to it, you'll notice that the score me button has disappeared. This is not something to panic about. What that means is that I've run the grader on it, which means that the grade has actually been recorded for you. And when I run the grader again, which I will, any changes or updates that you've made to the textbook will be accounted for. Okay. So if you see a grade and you didn't get 100% and you need to change something, that's fine. I'm also aware of some difficulties with chapter 2. I still have to check that out. So with the chapter 2 exercises with people not getting 100%. So I'll have to check that out with the specific students to see if it's the same issue or multiple different issues. But suffice to say, don't panic. If something is taking you way too long to work on, or there's a bug, it's probably, there's a good chance it's the problem and not, that's the system and not you. So let's see, we've got, so now with the quiz, okay, what I try to do is, because I've got so many of you, okay, that I try to reduce my workload by making my questions auto grade, okay, if possible. So what that means is that I've got an auto grader, a program that tests your program. Now, you might eventually take a computer automata class and find out that basically it's pretty much impossible to tell what a computer is doing. Write a program that simulates a computer and a program and figure out what the computer's program and the output is going to be. It's one of those kind of impossibility things, if I'm phrasing it correctly. So anyway, that said is that basically I can't possibly account for all possible answers or issues. Like I had one student who the auto grader didn't pick up on, and because they wrote a lowercase c instead of a capital C. That's
Hello?
okay. Hello.
What's up, Mr. Rosen?
Okay.
Do you know which room number?
110 AB.
110. Is it in the search building or the life search?
Circ.
Oh, okay. So 110 in search.
Yep. So so anyway, if that little change messed up the auto grader, and so that basically made it so maybe it couldn't compile or get all the credit, and it's like you lost 25%. No, it's just that the auto grader didn't pick it up. So that means that you'll need I'll need to go and check that later. If you don't mind, could you pull your mask up? Yep. Sorry. Don't. All right. So the so what's going to happen is that the auto grader can tell you if you're definitely right, but it can't tell you if you're wrong. That is what I'm saying. So if you're marked wrong, don't worry, that will get rectified when I actually go to manually grade the stuff around the time of the due date. Okay. What I'll do is I create a Google form and you can let me know what needs to be manually graded. So that way I don't have to necessarily look over every student's answer. Although again, this may change once we resume in person. What I will try to do this, what I'm going to try to do for the upcoming labs is start creating some small, now that we're back in person, I'm going to try to create some smaller quizzes, like 10 minutes, basically where you answer 1 or 2 questions in lab on paper, because they're the kinds of questions I'll be able to ask you, in a closed book, closed note sitting. Something like with a turtle program, which we're going over today, what is the output of this code? And right now, all we're dealing with is like variables and manipulating variables. Today, I will be introducing for loops, but you're going to have many introductions to the for loops, because the for loops are basically the first stumbling block for a lot of students. So I spend a lot of time going over those. But again, suffice to say, like, if you get a low score on the quiz, don't panic. It's probably, again, it's because the auto grader really only can check if you're fully right, not if there's like a minor mistake that you made that still generated a valid answer. And it's also a good thing that this week is the week we came back, because this is a bit of a lighter module, which is that we are dealing with debugging and learning how to deal with libraries. So especially turtles, in preparation for next week when we start doing using turtles and for loops together. All right, so the last thing I should mention is that if I do any quizzes, they won't be pop. I'm not going to say, oh, surprise, it's quiz time. Okay, they'll be announced, they'll be in your lab, they'll be short. Or I just might, for right now, I'll probably still do some online quizzes so that you can have those unproctored. But I'm trying to do, rather than doing big exams, I think it's much more beneficial to an introductory class to have multiple smaller, lower stakes exercises than what I typically do, which is 2 big exams and a final, even though those are easier for me to handle because it's just 2 things I have to grade as opposed and a final, rather than a lot of small things. So with that said, administrative stuff, let's go ahead and get started with today's exercise. So what you'll want to do, so first off, if you don't have a laptop with you, that is fine. In the future, if you can, try to get one from a kiosk. From one, I think there's one. Is there a laptop kiosk in this building? I know there is in Tuttleman. Yes. Okay, so there's one in the College of Engineering right around the corner. There's a laptop, and if that's the case, you feel free to leave at any point to go and swipe yourself in, or you can just do it on your own later. But the main benefit, normally in these kind of conditions, normally I would say if you don't have a laptop, just pair up with somebody who does. But that requires you being comfortable enough to get close enough to somebody in the middle of a pandemic. So not necessarily the best health advice there. So if that is creating issues for you, let me know, and we'll figure out a solution for you. But there is a laptop kiosk that you can just go over to, swipe, get a laptop from the College of Engineering, return it when you're done, because all the stuff, the vast majority of the time, what we'll be doing in class is on a web page. So to access today's web page, you'll want to go to modules, go to module 3. All right. And then scroll all the way down for the Tuesday and Thursday's lecture. And we're going to go ahead and click on this. We'll do the project. So, and that will give you the link. Now I'll go ahead and drop this link in Discord and in Zoom for the people who are logged on to Discord. I'm still trying to figure out if I should like partition this at all, like saying, but all right. So there, that's easy, but otherwise just log into Canvas, hit module 3 and get to this page, which is drawing a circle with a turtle. This is going to be our first lecture on for loops. We're going to be doing a number of exercises that concern ourselves with for loops. Now, the videos haven't gotten to the point of for loops. So if you have no idea what a for loop is, I did kind of mention it in passing a couple lectures, like last lecture. It's perfectly okay that you have no idea what a for loop is. Make sense? So, but for today, we are going to be working on drawing a circle with a turtle. So now to remind you, turtle is a module built into Python where we can just type in import turtle, and that tells Python to load up the turtle package, right? And and then we use the magic phrase to create a turtle. I like to call my turtles Alice and Bob, and I prefer Bob because it's very short and I only have to hit 2 keys on my keyboard. But we do Alice and Bob because A and B, and then it's a very common thing in computer science. And then if we have a bad actor, if we have a malicious actor in a security kind of situation, that's often kind of called malicious Mallory or malicious Malcolm, you know, because it's easier to remember names than just A, B, and M, right? So anyway, Bob is going to be my turtle, and I'm just going to sit, and the magic phrase is turtle, which says, hey, you know that package I just told you to import? Yeah, dot, look inside of it, right? This is magic. You don't have to fully understand how it works. And then this is the part that's most the magic, which is something called a constructor, which gets into objects, which is covered more in the next class. But this creates a turtle. It constructs a turtle. It makes a new one, and it stores the all that information in the variable called Bob. And then we can save it and run it. It's not really going to do anything. And then what we need to do is we say we can make it do stuff like Bob dot forward to tell it to go forward, right? Go forward 50 pixels, which is 50 of those tiny squares on your screen. Now, just to remind you, the way to view this is that you are looking at a bird's eye view down on a giant canvas of paper. Your turtle over there has a little marker that's attached to his tail, and he's dragging that marker along with him everywhere he goes. Make sense? Right? He's just simply drawing along stuff. And so that is how we are doing graphics. Because it's very easy to see your output, and it's much less mind-numbing than looking at text, which can be very mind-numbing. Okay. Now, what our objective today is to build up to drawing a circle with the turtle, which I'll point out is not even a task you can really do on paper. Like, it's really like if I really wanted to be a semantic jerk about it, if you try to draw a circle, I can point out like there's some kind of imperfection in it. You didn't really draw a circle, you drew some kind of wobbly shape that looks like a circle, something that resembles a ring, but it's not quite there. If I wanted to really be a jerk about it, I'm like, well, if I zoom on to the atomic level, it's certainly not going to be perfectly circular. Again, if I'm going to be a jerk about it. And so as we're going to see, we really can't draw a circle on a computer, but we can get close enough that we can make it look like a circle. But before we get to there, we've got to do stuff, which is we're going to work on this first exercise here. All right. And we are going to draw a triangle. So our task here is ask a user for the side length, then draw a triangle. The next task is to draw a square. And I'll work on this first one, and then I'll give you a bit of time to modify what I've created so that to make it work for a square, which won't take too much. And then we'll see the next one after that is not too much. And then we're going to learn how to modify this. So, and somewhere for loops are going to come into this whole thing. And again, everybody can hear me over there? Okay, great. Just want to make sure. Let's see. So Now let's go ahead and create, so we've got our instructions here are ask a user for the side length and then draw a triangle. So right now, what I'm going to do is I'm going to create a variable called side, and I'll figure out the whole user asking for it right now. And I'm just going to assume that we want to draw a triangle, and I'm going to make an equilateral triangle, right? For those of you who need to dig up that memory, equilateral means all three sides are equal, because that's the easiest for me to draw. And also all the angles are equal. So I'm going to just say I'm going to make a side 100 long. And then when we deal with, we'll deal with the user input in a bit, right? Partition this problem up. So we create our turtle. I'm just cutting and pasting, and we dictate that we want to go this far. And then we say, Bob, move forward side. And what's going to happen is that we're going to look at side. We're going to evaluate it. Basically, Python's going to go, ooh, side, that is 100 long. So move forward 100. Okay. So what I need to do to create a circle at this point is, and let me go ahead and annotate, is that, sorry, to draw a triangle, that's my goal here, is that I need to draw a line that goes here and a line that goes here, except actually the turtle's going to do it better because, and not have all these weird crooked bits, right? Right. So first off, what do I need? What is the first step to go this way? I have to do what? Yes. Yeah, I have to change the heading. I've got to turn left. Yeah, got to turn left. So the next question is, how far do I need to turn left? And this is somewhat of a trick question, so don't feel bad if you give me the inverse. 120 degrees, right? Because normally we think of we'll get there. The comment in the chat, we'll get there. These three angles are in an equilateral triangle are always 60, 60, and 60, right? And we see them, and so we often add up. Okay, so triangles have a grand total of internal angles of 180 degrees. But these, to draw it, we've actually got to make a 120 degree turn, because we have to turn 90 degrees this way. Turning 90 degrees left would bring me up here, which is not there. And then I need to turn 30 degrees more to get here, right? It's kind of the complement of that angle. So, or that. So, and then the same goes over here. I'll need to turn and turn again. So, but let's go ahead and just take that at a time. Just do that step. Where is, oh, there, mouse. Okay. Okay, so now what we're going to do is that we are going to say Bob dot left 120 degrees. And then we'll move forward. And now that he's in the right setting, we'll do Bob dot forward that amount. Awesome. And we will go ahead and run it. And hey, look, ooh, my drawing doesn't look so bad now. Kind of. Okay. So clear that drawing. And so now that we've got this, we need the turtle to go down and this way, which means that we need to turn, well, not, I drew kind of a 90 degree angle, but we don't want a 90 degree angle since that gets us off course. We want 90 degrees plus a little bit more, which is another, which is another 120 degrees. So we turn another 120 degrees. And then we move forward again. Okay, and there. And actually, what's cool about this is that we end up back where we started. And if we really, really, really want to end up back in the exact same way we started, just for the sake of symmetry, what I can do is I can turn left another 120 degrees. And what that does is that turns him back into the original position that he started in, right? So move forward, turn 120, move forward, turn 120, move forward, turn 120. What's the total amount of degrees that he's turned? 120 times 3, which is 360 degrees, which is the full length of the circle. So we've drawn a triangle. Now, a couple things we can do about this, or one thing that we might want to do about this, though, is that essentially what this is I've written the same lines, the same group of lines 3 times, right? Essentially, what did I do? I just could effectively have done this and then done copy paste 3 times, which is fine for a triangle, I guess. But if it's like if it's a megagon, a 1 million sided 1 million sideagon, things you look up when you're teaching 5-year-olds about shapes, it basically, you know, be a bit much to do, you know, a bunch of copying and pasting. Or even if I'm doing a sevenagon, right? 1, 2, 3. Wait, how many did I do? Did I do enough? Oh, geez. I don't know how many I put in there, right? Even a small amount, it's easy to miss that. Your brain and your eye system especially is designed for making very quick assessments using a set of heuristics. These kind of assessments are very good at keeping you alive. They're the kind of things that allow you that work in combination with your system of feeling and your system of balance, that allow you to catch things that you are accidentally dropping. Or you've seen those dad reflexes kind of videos where basically a dad will reach out and just grab a kid who's falling and nobody's even noticing, right? And he wasn't even paying attention, those kind of things. But so there are things like that. Your brain, your eyes are set up for very specific purposes, and reading carefully wasn't necessarily one of them. For example, I have a deliberate grammatical error in my teaching statement. If you wanted to go and read it, where I use, which is a very common one, which is I have the word the in the sentence twice in a row. The mind just reads the as the. It is just one of those common things. Or so the point I'm saying is that it's very easy for you to miss minor things. And so best not leave it to chance, and instead best to, like, if we're copying, pasting, or repeating something, it's best to just be explicit about that. And we have a tool for being explicit, and that's called the for loop, explicit with repetitions. Now there's 2 types of loops, and I'm going to get a bit technical here. There's for loops, which are determinate, and while loops, which are indeterminate. We'll learn about while loops and indeterminate loops later, but that just means that we use a while loop. They're better suited for when we don't know precisely how long something's going to go. The for loop, that's good for when we know exactly how many times we want to do something. It's determinate. We can determine how long it's going to be. Now, what's interesting is that you don't need both. You can use one or the other. It's just nice to have both. So we're going to learn about this for loop right now. Now, the for loop has kind of 2 big use cases, which is iterating and counting. So the first, and the counting is specific or repeating. So we'll do that first. And the way it works is for I, we typically put I here, but we could easily put underscore to say we don't care what the variable is, or count over here. It doesn't really matter. But typically we use I because we're counting up a number, or I for index. It's an abbreviation, but we could put whatever variable name there. And this is the important part. In range, and then a number. Here we want to repeat something 3 times, so we put in 3. Okay. And then whatever we want to repeat 3 times gets put inside this for loop. It's indented inside this for loop. So that is the way it works in Python. To figure out what is part of something, what is inside another block of code, you use indentations. Specifically, you use colon to tell Python, look out, there's an indentation coming. And then you have this stuff indented. So I can be whatever you want. It doesn't really matter. Blank over there could be just fine. But basically this says repeat the following 3 times. Do bob forward, then do bob left. We've done it once. So now do bob forward, do it. Let me draw that out actually. Draw it. So the way this would work is it would go say, okay, there's a for loop. Do bob forward, then turn left. Okay. Second time around, do bob forward, then turn bob a bit to the left. Okay. Bob forward and now turn a bit to the left. Okay, I'm facing this way. So we do it, it will just simply repeat this code, this block of 2 lines 3 times. And so it's exactly the same as basically just copying pasting the code 3 times. So what's cool? So now let's see, let's go ahead and run this and save and run. And we see that it just repeats, it did exactly what we're doing. So this just form means do it 3 times. And like I said, what we put here doesn't really matter for I. So if I do for I, it'll come out as the same thing. Yeah, I zoomed out. Or if I put for blah, or if I put for blah, 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 right? It doesn't really matter the name, or at least it doesn't matter yet. Although we would get in trouble if we use side because we're already using that name for another variable. If we put inside, we'll get into a heap of mess because we're changing what side is. And in case you're wondering, that incremented a bit. So, so what range does is basically, so what this does essentially is it's saying, hey, I've got a value I, and I want to give it a few different values. I'm going to do this 3 times. The first time the value will be 0, then the value will be 1, and then the value will be 2. We don't need to worry about that yet. That's the way it works. What range does is that it creates a range of values, except that's a total I. That's how it worked in Python 2. In Python 3, it generates a range of values, which is so far and beyond this that we don't need to really understand that. What's important is that when we write in this form, it will run 3 times. If I do 7 here, then this will run 7 times. 1, 2, 3, 4, 5, 6, 7. Right? Now because if you follow the directions like in going around and around and around, it's not going to, we're just drawing over the same line. We're not really going to change anything. Now, it is possible to change things while we're going through loops. That's a discussion for another day. But for right now, we just want to master this form. Okay. Finally, let's add in this last part, which is ask the user for a side length. So instead of saying side is equal to 100, I'm going to say, hey, int, how big is each side? Oh, sorry, not int. I got ahead of myself. Input, which triggers the input prompt. How big is each side? Question mark. And then I'm going to put it, okay. Then I'll put in a space there. And then what I'll do then is that the user will enter in some text. That's a string, and we can't do numerical operate. And when we move forward, we don't move forward amount that's a string. We need it as a number. So I'm going to turn it into an integer. So take in text, take that text, turn it into a number, and store it inside. So now I run it, and how big is each side? Let's go with 150. And now we'll see that we are drawing a slightly bigger triangle. All right, so what I'm going to do is I'm going to hit the share code button. So if you've been furiously copying that down, prepare to feel a little sad because I just simply shared that. And all you have to do now, I believe, is that if you reload the page, you can just hit load history and you'll be able to see that, hey, this code was shared by your instructor. Okay, so now let's go on to the next step. Ask the user for a side length and then draw a square. So use this code that I've given you as a base and take maybe 3 minutes to just convert it into a square. Don't overthink it but now just work on turning it into a square, right? A four-sided equal polygon. What's that? Four-sided regular polygon, that's the term. Meaning you have every side and every angle is good. We're working with regular polygons. Okay. So let's see. So 233, I will resume. And then I will leave this up here in case you need to see it.
Oh, no, I'm just.
Oh, okay. He just looked like a hand up.
15 all streets.
All right, it's okay if you didn't get there fully. By the way, so for this, to start this off, I'll just simply do Control C and copy and paste. So this is the by the way. It's very convenient that basically every single important keyboard shortcut is located right next to each other, and you should get used to them. And start. I've kind of developed a twitch, and it's very common where basically it's almost instinctual to hit Control S or Command S on a Mac for save. So get used to that one. Other useful ones that are all together: Control A to select all, Control Z to undo what you just did, Control Command X to cut, Control C Command C to copy, and Control C Command C to paste. Get used to using those rather than using your mouse. It's much quicker. So to deal with this and draw a square instead, well, first off, we're dealing with 4 sides. So we want to repeat an operation 4 times, right? So we want to switch this from 3 to 4. If we left it at 3, we would just get, when we're done, we'd only get we'd get kind of a sukkah instead of a little hut instead of a square. On the other hand, we need to change, go a different amount of degrees of when we turn, right? Because when we turn, we're going to want to go this way, and then we need to turn left, and you could optionally turn right if you wanted to, and go up and go 90 degrees, right? So we're making 90-degree turns now. 4 90-degree turns, right? Which conveniently also adds up to 360 degrees, right? I mean, technically, you only had to do this turn, and this turn, but doing the 4th one makes it nice and symmetrical, which is important because that keeps our math nice and simple. It makes it all add up to 360 degrees. So we change this to 4, we change this to 90. Okay, save and run. Let's do 200. And we'll see that that kind of draws a square there. let's back off just a little instead of that and do maybe 180 aside. So it stops a little bit. And so now there we go. We've got a square. Not too much to do. And again, if you weren't able to get that, that's okay. It's all very new. I'll share the code anyway so that you have a record of it and you can run it yourself. All right. Ask the user for a side length. And now draw an octagon, right? Ask the user for a side length and now draw an octagon. So again, octagons, 8-sided. So now go ahead and take a couple minutes, right? Give you another 3 minutes until 2:39 to work on that, but it shouldn't really be much different, right? We're going from 4 sides to 8 sides, okay? Mhm. And again, I find like the underutilized tool of pencil and paper to be absolutely critical here if you're having trouble, because you can draw out your problem of what needs to be done, right? Which is, how much do I need this guy to turn? All right. So for that one, right, same thing here, except with 4 sides, it's now 8 steps because we're drawing 8 sides. And what we need to do is we've got to change the angle now from being 90 degrees to, well, this needs to be about half of a 90-degree angle. And it becomes a 45-degree angle. Assuming I can draw correctly, which is always it's a crapshoot at best, to be honest. So 45-degree angles. And again, and conveniently, 45 times 8 becomes 360, right? So if I do 50 for each side, we get that. So all I did was change this number and the angle. In fact, actually, kind of just conveniently here, I should point out that for each of these, really what we're doing here, the amount we need to turn is 360 degrees divided by the number of sides, right? So 360 divided by 3, which is 120. 360 divided by 4, which is 90. And 360 divided by 8, right? I'm just simply dividing by the number of sides we have, right? To get 45. That's what it comes down to. It's just kind of I've just kind of unfactored it or reversed it. Your computer's perfectly capable of doing math, so why not make it do math? So again, let's do a size 70. Here we go. And so it does it fine. Now, also what's interesting to note is as we increase the number of sides, the figure we're drawing begins to resemble a circle, closer to a circle, right? This is not a circle, right? But it's more circular than the square was. Okay. So and yeah, we can't draw a perfect circle on that, but that's okay because we can't display a perfect circle either. Remember, we're talking about pixels here. Your computer screen is made up of lots and lots and lots of tiny little boxes. Specifically, if you're using a 1080p monitor, which is the vast majority of the laptops in here, then you are using 1900 and there are 1920 by 1080 small little squares on your computer screen. That's what the 1080p means. It means it's the number vertically of how many of those little pixels are, how many vertical pixels, and most are in the 16:9 ratio, meaning there's a 16:9 ratio of horizontal to vertical pixels. Older computers used to use a 4:3 ratio. That's why you see older television shows in that, because they were filmed in that ratio. And you can get setups such as some Apple likes to do maybe a bit of a different ratio, and Google does as well. We're starting to see different ratios, but the vast majority is 16:9. But anyway, if it's made up of little circles, then if my shape is made up of tiny little squares, then there's no way I can make an actual, honest to God, mathematically perfect circle. I can just draw something that looks to the human eye like a circle, right? Makes sense? It looks close enough. And so let's go ahead and just kind of see what I mean, right? If I do this and I say, hey, let's up this to 20 sides, right? How many, by the way, what angle should I be doing? If I'm doing a 20-sided regular polygon, a 20-agon. I don't know. When the computer, you do it, computer. I'm going to type in 20. There you go, right? So it would be, so that makes it easy, right? Make the computer do the math. Don't let So let's go ahead and do 30 on each side. And notice that looks a whole lot like a circle, especially as we get smaller, right? If I make it 10 per side, that really looks like a circle, doesn't it? So the key here is that if we make it small, if we make a polygon with enough sides, it's going to resemble a circle. All right. Right, that looks pretty darn close to a circle. All right, so the idea here is the right. So we'll just simply make a circle that's by making it a bit bigger, by have more sides. And then the question is, we need to generalize for a given number of sides how many turns we need to make, and I've kind of already done that for you. So so now we're getting on to the next portion, which is that, hey, let's go ahead and ask the user for a radius, all right? And then draw a circle with that radius. Okay, but wait, how do I get from there to radius, from the length of the size to radius? Because what we've been doing so far, right? What has that been? We've not been dealing with radius, or in other words, we haven't been dealing with, here the side length was how far across we'd go. But here, right? We had a 20 side, but this is much more than 20. So how do we get from here to there? Well, a bit of math, right? And I'm not going to bother jotting it down on the screen over there because you wouldn't be able to read it there. Wonderful thing about touchscreens, right? Okay, so if I've got a radius, right? If I've got a radius r, then that gives us some relationships, such as what the total perimeter size is going to be. We have a special word for perimeter in for circles. What's that word? Circumference. One of my favorite little puns from fantasy is that in the Discworld series by Terry Pratchett, he has it's a flat world and there's a fence that keeps everything from falling off, which is called the circumfence. It's a dumb joke, but it always made it stick for me. So the idea here for the circumference is that has a formula, right? That has a specific formula, yeah. Circumference is what? 2 pi r, right? 2 times pi times r. So that's kind of like our perimeter, right? It's kind of like our perimeter, except it's not as cool. It doesn't have as cool of a name, right? So so that's kind of like our perimeter. And the perimeter in a square, right, is just adding up all the sides, right? So this would just be the sum of all the sides that we put together. So if I'm doing a 20 sideagon, then each side would want to be 1/20th of this amount. If I was drawing a circle with an octagon, I'd want each side to be 1/8 of this amount. Everybody following so far? Right, 1/8 of this amount. So so the first thing we want to do here, right, is that we get our side length from, so we get our radius from the user. Radius, and I'm going to do it as a one-liner, is equal to, let's go with int anyway, int input. So take the input and then throw it through the int function. Enter, whoops, gotta remember to use quotes. Enter the radius. Yeah, I could call it R, but radius is easy to read, you know? You don't have to make the mental jump, that extra mental step of R is equal to radius. So now that we've got a radius, we need to figure out how big the side length is. And the side length is equal to that formula I just wrote, which is, well, first we want to know, actually we should do, let's create a variable called num sides is equal to however many you want to do. Let's say I want to do a 45agon, okay? In other words, a shape with 45 sides. You can do whatever you want, yes. We will do that, but yes, we do need to import it. I was just kind of focusing on this amount, right? So then the length of an individual side would be 2 times pi, and there's a couple ways we can deal with pi in a second. So 2 times pi times the radius divided by the number of sides. Now remember, order of operations does take effect here, so you know, but that's not something we have to worry about too much in this kind of simple formula like this. Right? So 2 times the radius times pi times the radius, that's our circumference. Divide by the number of sides, that's how much we want the turtle to draw at each step. Okay? Now, as far as pi, if we try to run this right now, we're going to get an error, of course, which is whatever I put in, because it will say, hey, pi is not defined, right? Pi is not defined on line 3. Okay, so now we need to define pi. Now we can put in a literal. We can put in the value we've always learned for pi, which is 3.14. If you know a couple more digits, you can put them in, right? But honestly, and if you really wanted to get specific, you could import the math library, which contains all those mathematical functions you'd like not to think about, like sine and tangent. but also has things like pi. So I could just get it from there by typing math.pi. But again, that's kind of overkill here. So if I wanted to find my own pi, I could just do so like this. Pi is equal to 3.14. Assuming I can type, okay? And now we can just print to check if this works, which what I'll do is I'll print out this much, and then I'll print out side. And what this is going to do is it's going to print out the circumference and the individual side, and we'll do 80, and we have a circumference of 502, and okay, I guess that looks like 1/45 of that because I was using 45 sides. Okay, so now that we've defined how long our turtle is going to go, we're going to definitely need to make that turtle. Import turtle. Always good to put, you could put that, now we could put that turtle anywhere before we start putting the turtle, but it's always good to keep your imports organized at the very top of your program. Make sense? Like even later on, if you're using individual functions, some students will like import it inside. Don't do that. That's bad form. All your imports go on the top. So because that's just easier for us to read. So import turtle. Now let's say turtle. Sorry, Bob is equal to turtle. Let's make our turtle. All right. And now here's what's pretty cool, right? For in sides, sorry, in range. Now here's the cool thing. Earlier on, we were putting in a literal over here, right? We were putting in 4, we were putting in 8, but there's nothing stopping us from putting in a variable here. Here, I'm going to put in 45, right? Or rather, I would put in 45, but if I decide to change this later, then I don't want to change it in multiple places. That's why I made a variable. Here I can put in, whoops, I'm dropping in the wrong place. That's what happens when you talk and code at the same time. Okay. Here I drop in, instead of dropping in 45 or some other number here, I'm going to drop in the number of sides. Make sense? And so now what I'm going to do is that I say, okay, I want Bob to move forward, okay, a certain number of squares, which is the side length, sorry, some number of pixels. And then I want Bob to do, and then I want Bob to go left. And how much do I want him to turn? Well, the amount I want him to turn is 360 divided by the number of sides we've had. Does that make sense? Does that part make sense? Because that's what we've been doing over here. That's how I rewrote these. For a 20-gon, we divide by 20. For a square, which I almost called a 4-gon, that's 360 divided by 4. Right, because we want the total amount, when we turn, we want the total number of turns to add up to 360 degrees. So let's go ahead and run this, right? So, and let's go with a smaller number because we've got a lot of sides, 20. So I think I can up that. Looks pretty good, though. 80. Yeah, you can, that looks like a circle, yeah? Okay. And what's cool about this is because of the way I've set up the variables, because I have this for loop taking in a variable over here, and we're dividing by the number of sides, and we're dividing by the number of sides over here, because we are doing that, okay? Because we are doing that, if I want to change the number of sides, like to lower it, to make it go quicker, because there's less drawing involved, all I have to do is just change it in one place, right? If I'd used a literal, if I'd been using 45 literally in a bunch of places, instead of a variable, I'd have to change it in like 3 places. So yeah, Yeah, radius. So let's go with 100. Let's go with the radius 100. And now we can see that with 20 sides, it looks like a circle, but we can also tell that it's clearly not a circle, right? All right. So we've achieved our goal for the day, but that's not all, because again, there's still 25 minutes left in class. So there is one kind of just like little thing that bugs me, of course, which is what? Well, the circle we draw, it doesn't start, we drew it, and it's not in the, and it's in the center, it's not in the center, right? If we want to draw a circle, it makes more sense that we'd like want to draw the circle around the starting location. Okay. I want my circle to be here, all right? Now, there's a couple of ways we can go about that, but that's what I'm gonna let you focus on for a good amount of the next portion. So ask the user for a radius, then draw a circle with that radius, but make the center of the circle at the current location. Okay. So so in other words, what we need to do is that we need to kind of adjust where we start our drawing. Now, there's a couple tools to help us with that, a couple of turtle commands, specifically bob.up or turtle, any turtle command, whatever your turtle's name is, and bob.down. Now, what does that do? That tells it to, well, remember, we're a turtle dragging our tiny little tail, or at least Bob is. That means that as he moves, he's dragging this pen across the paper. So if I tell him up, that's telling him to lift his tiny tail so that the marker's no longer dragging. So he can move freely. Let me go ahead and just kind of show you that without. So here, what I'll create Bob, and then I'll say Bob.up. And if I run this, let's do 100, we can see here that Bob is moving, right? We can see Bob moving, but because his tail is up, he's not leaving a trail, right? So, and if I actually took this, right, I find this pretty funny, pretty cool how I could do this. Bob.up. And this will actually get the point across, I think, very nice and dramatically. Copy paste it, pop that down. And now here I change the number of sides. Each time this loop runs, it's going to be half of the full circle, right? That's what the divide 2 means. I'm doing it half the number of times. Let's change this also to, number sides. So that's good. It's a nice even number. Let's do a circle of 150 radius now. Oh, what did I do wrong? Float cannot be determined as right. It has to take in an integer for range. So now remember, dividing. If you get this error, what happened there? Well, I divided, but initially what I was doing was I was dividing by 2, which gives me a floating point number, right? 2 points. It gave me 10.0. But Python sometimes, the range function is pretty strict. It doesn't want a double. It doesn't want a floating point number. It wants an integer. It wants a whole number. So we're going to use divide, which is our 4th grade division again, right? 4th grade division, meaning that we basically do just quotient and remainder. And here this gives us the quotient. Okay. So here we're going to do again 150, and now you see that he goes across for half of it, and then he draws the other half of the circle, right? So up, he lifts his tail, draws half the circle, and then down, he draws the other half of the circle. And I just made it a bit bigger than the box, so let's go ahead and fix that. So, yeah. So what he did is that he went around, drew half the circle with his tail up, and then drew the other half with his tail down. Make sense? So that allows you, so that means that we can kind of silently move the turtle to where he needs to go for this portion of it. So go ahead and try your hand at this one. This time I'm going to give you 10 minutes to do this one, okay? And then once once you're done, I will go ahead and reveal the answer. And then it will be, it will be time for us to go. So let me go ahead and, by the way, just share this code with you so that you have it, right? That way you have something to work with. It's because, nothing made it more difficult for me to pay attention in class than to try to copy down notes verbatim, right? So, I would be focusing more on what was going on than the actual, more on the notes than the actual content. So here, right, all you have to do is reload the page and you can hit load history and you've got it. Okay, so you can use that as the start for this. Okay, and the idea here is that we want to make the center of the circle to be the current location. And my hint is that we got to move the turtle out of the way first. So question in the chat, I have this error where when I keep trying to do a down radius, you don't go down, right? The commands are either forward or backwards to move. Down doesn't take any arguments. It's just up or down. That's it. You just move your tail up or down. So it doesn't take any arguments. If you, the commands that turtles need for numbers are forward, backwards, left, and right. And it's, forward and backwards that moves the turtle in the obvious direction, the least surprising, I should say, the least surprising. And left and right turn the turtle left and right respectively. Yeah, it's not that's a term I'm trying to use more. Not so much obvious as the least surprising. Yes. How many sides does the circle function have? You mean the you want to just try to do it by yes. Because what the up and down can do is that you use that long. That's the point of putting it down. It helps you remove that.
Is there commands like for it to run? It's hard to see like the picture one.
I would, the easiest way to do that is to reset your zoom.
It's not that big.
You can look up turtle.speed, which changes the speed as the turtle goes.
So the object is to get the circle in the middle.
Yeah, to get the starting point of this, to get the starting point of the circle kind of at the center location. It's always going to be a little bit off because of because the tip of the arrow, it's going to look a little bit off because the tip of the arrow is at the starting point. All right. So let's go ahead and get to it. So what we're gonna do is that, what we need to do is that we have to take, in order for this to work, right? Cancel. Go ahead and remove this and remove this and remove this and get this back to normal. In order for this to work, right, what I need to do first is I need to move this turtle down like over here, right? And then at that point, the turtle can draw the circle. We'll use that term gently because it's more potato shaped than a circle at this point, right? The turtle will then draw his circle and then he'll move back to the center because I like starting where I ended, okay? That part's not necessary, but it's just what I like to do. So we'll move down, draw the circle and draw and move back up, okay? Now, the couple things here is that let's get this movement down first, and then we'll work on the part where we need the down and up command for, okay? So to move him down, well, if we want the circle to be centered, then the amount down we have to move him is equal to the radius. We want him, right? Because if we want the circle to be around the center, what makes it a circle is that we've got this drawn circumference around a single point, and that drawn circumference, each point along that is radius distance from it, right? It's a bit of a technical way to put it, but basically, if we move him down a radius amount, then he'll be able to draw the circle that will go around the center. Okay, so what we do is that we do Bob. So what I'm going to do is I'm going to say Bob dot right in this case because I want him to move down. Bob dot right, go down 90 degrees. Sorry, turn 90 degrees. Bob dot forward. And the amount it needs to go forward is the radius, the total full radius. And then what he's going to do is that he's going to turn, now that he's moved down to the radius, in order to start the circle the way he's been doing it, he needs to turn to face the way he was previously, which I just do by doing Bob dot left. You could easily just do, you could just as less easily do Bob dot right 270 degrees, but because that would give you a full circle, but let's go ahead and run it. So 100, and now he moves down. So now we see his path, what he did. He moved down. And notice that we've got this line sticking out here. This is because, right, as I mentioned, his starting point is over here, and he's kind of starting at the tip point. It becomes much less obvious, though, if I increase the number of sides. I'll go ahead and increase that to 60 now. And then I'm going to say, let's have a radius of 180, because now that we've moved down, we can kind of see it a bit better. So we move down, and that looks a lot better. Still a little off center, but that's okay. Okay. But it looks a lot like a circle. We see it's a bit off sides here. Specifically, the amount it's off sides is the length of this is like the length of however big this turtle is, okay? Not too big a deal. We could, let's see, Bob dot, let's see. So he is, we could do is we can try moving him forward a little bit in the beginning. Bob dot forward, say like 5 pixels, and let's see how much that works. This part I've not actually tried before. Now that was the wrong way, right? Just made it even more off kilter. So Bob dot backward. Let's try 15. Probably happy medium is that he's 10. So I'm going to guess now that he's 10 pixels wide. This is just a bit of guessing and and testing, which is sometimes it's necessary for graphical programs. And that looks about center, right? So now we've just got this odd little hook shape. Like I said, you didn't have to worry about this part over here. This is the first time I've ever actually tried accounting for that. So what I'm going to do is I'm going to say, hey, Bob, lift your tail so I don't see you dragging yourself into position. And then Bob dot down. Right? 180. And now it really is going to look like a nice and centered circle. Right? Okay. But now my turtle's over here as opposed to where he was in the beginning, which is the center, which personally for me, that strikes me as wrong. So what I'm going to do is I'm going to grab this block of code over here and I'm going to kind of invert it because I want him to move back to the center. That's just personally for me. That's so here, right? I'm going to lift my tail again and put it down when I'm done. So what I'm going to do is I'm going to go ahead and basically reverse my steps. So I want to turn up, which means I'm going to go ahead and turn left 90 degrees to go point myself back up, move forward 90 degrees to bring myself back up to that location, turn right 90 degrees to point myself in the initial direction, and then move back into position, into that very center position that I was originally in. That forward 10 is just to account for how big the turtle actually is and the fact that he takes up some space, which is unnecessary, but I just want, it was bugging me that it was kind of off center. So there.
So what I did, I thought it was a little bit, I just went back by the radius, turned right, and then it's like right on where the edge of the circle is.
Did it work? Did it draw it fine? And then that's fine. I don't really care how you did it so long as it worked. But again, we're more checked when I grade this part, it's going to be checked basically for participation. Did you fill it out? Did you run it? So remember at the bottom, please answer these post-project questions, which let me know how you're doing on this one. And they also, part of that is to get your points. So otherwise, we're done with today's lesson. Tomorrow's lesson, sorry, not tomorrow, but Thursday, we'll be going over a more abstract kind of numerical stuff, which is using for loops to approximate pi. The idea here is that, we'll get into pi and irrational numbers in a much more kind of easy approach way. But and then on your homework for this week will be on turtles, right? Doing things like drawing the Olympic rings for the turtles. Or writing your initials using turtles. And my apologies to anybody who has a curve in their initials, because that will make it a bit more difficult if you want to put in those curves. So, all right, let me go ahead and stop the recording. Then you're going to get very familiar with block curves.